The topic for today is data analysis and visualization with Microsoft Excel. And you will need Microsoft Excel installed on your computer if you want to follow along. Fortunately, there is a 30-day trial available of the program, so you can download it and you can use it during the trial period and try and work through this notebook. But otherwise, you can also follow along in any other spreadsheet software like Google Sheets, although some of the things may be a bit different. So here are the topics we're going to cover in this tutorial. We'll start out by just talking about spreadsheets and Microsoft Excel. We will take a quick tour of Excel's user interface and functionality. We will learn about using formulas, arithmetic operations, and functions in Excel. We will talk about data analysis and visualization of some real-world data with Excel. We will also look at some advanced features like data validation, conditional formatting, and merging cells. And then we'll talk about cloud-based spreadsheets for collaboration and the benefits they offer. Now there is an Excel workbook that you need to follow along with this tutorial. So you just need to click on this link and it will download an Excel workbook for you, an Excel file, and you will need to have Microsoft Excel installed to open this workbook. But before we do that, let's just talk about spreadsheets first. And a spreadsheet is simply a computer application for organization, analysis, and storage of data in a tabular format. So you have some tabular data. So you put this into this grid-like structure where you have some rows and columns. And then you can also perform operations on the data that has been entered in the cells of this spreadsheet. So cells may contain numeric or text data or the results of formulas like this one that automatically calculate and display a value based on the content of other cells. So for example, here we are calculating the standard deviation of all of these numbers using a formula. And anytime you update any of these numbers, the standard deviation also gets updated. So spreadsheets are very convenient because they allow you to look at data, perform computations, and not worry too much about writing code or performing mathematical operations in your head. And they're very easy to update as well. If you change a value in one place, whatever values depend on it automatically get updated too. And Microsoft Excel is one of the most popular spreadsheet software applications, and it's used for a whole bunch of different purposes, but primarily data entry and storage. A lot of small businesses and even large businesses run on Excel. They put all of their information into Excel or a spreadsheet for performing calculations, things like how much profit did we generate today? What does our month-on-month growth of sales look like? What do our projections look like? For data analysis and interpretation, for reporting and for visualizations, creating a quarter-end report, creating an year-end report. A lot of these are created using tools like Excel. For accounting and budgeting, identifying where we're spending money, creating a budget, and making sure that all the numbers add up properly. It's used for collection and verification of business data. A lot of forms are used in businesses and all that data is often fed into a spreadsheet. It's also used for scheduling and for calendars. A lot of people tend to manage events using Excel. And then people use it for administration. It is also used in statistics for time series forecasting in many domains, and sometimes to automate repetitive tasks, especially those which involve mathematical computations. So Microsoft Excel is available as an application for desktop computers and for mobile phones. We will be looking at the desktop version, which has far more features, and the mobile version is somewhat limited in that respect. It is part of the Microsoft 365 family of products. So you can check it out here. You go to Microsoft.com or just search for Microsoft Excel online and that will bring you to this page. And here you will be able to try it out. So you can just click try for free for home and download it to your computer. And once you download it, you will be able to open it up. And this is what Excel looks like. So when you open up Microsoft Excel and you create a new file, and files are called workbooks in Microsoft Excel, this is the window, this is the UI that you should be seeing. Now, of course, depending on whether you're on Windows or on Mac OS, you will see a slightly different user interface, but most parts of the UI are quite similar. You can use any recent version of Excel. Now, you don't have to use the latest one for this. And make sure that once you've downloaded Excel, you also download this workbook and open it up in Excel. And this workbook should look something like this. So there should be a bunch of sheets within this workbook. And if you do not wish to buy Microsoft Excel and you're not able to start a trial, you can also use Google Sheets. Go to sheets.google.com. It's free and you will be able to replicate most of this tutorial, but there will be minor changes which you will have to look up. So let's quickly look at Excel's user interface. When you open up Excel, this is what it looks like. And this user interface has 5 main parts. We come from the top. This is the title bar right at the very top. Then you have, this is called the ribbon, which looks like a menu bar, but then instead of opening menus, it opens up this toolbar of many different action buttons. Then you have this region. This is called the formula bar, and this here you have the sheet that we're looking at currently. And then finally you have a bottom bar. Okay. So here's the title bar. It shows the workbook name and it shows some quick actions that you can configure, like just saving a file, undo, redo, things like that, and turning on autosave. Then below the title bar, you have the ribbon, and the ribbon contains a bunch of different tabs. And as you click on each tab, you can see some action buttons under each tab. So if I come back here, you can see currently we're on the home tab of the ribbon, and I can also check the insert tab, the draw tab, the page layout tab, the formulas, data, review, view, and sometimes a few more tabs show up depending on the context. Like if you have a chart on the screen, then another tab shows up for a chart. You can also hide the ribbon if you just click on the tab name again. So now the ribbon is hidden, and then you can open up any tab in the ribbon like this. So most of the common operations that you will perform are part of the home and the insert tabs within the ribbon. Next up, you have a formula bar. This is where you can type mathematical operations and functions into Excel. So here you see the formula bar, and you can start typing some formula here, and we'll see examples of that. Next, you have the sheet, which is the biggest part of the entire UI, and this is where we put in all our data. For example, I can put a number here, 1, 2, 3. I can put some names here. So this is a grid of cells, and maybe I'll just zoom in here a little bit. So this is simply a grid of cells, and that extends to a pretty large number of cells, both in the horizontal direction and in the vertical direction. And you can see that the columns of this grid are numbered A, B, C, D, E, F. And then the rows in the grid are numbered 1, 2, 3, 4, and so on. Then you have the bottom bar, and this is because a workbook can have multiple sheets. So this is sheet 1, and then there's another sheet called introduction, and yet another sheet called strings, formatting, arithmetic. So at the bottom of every workbook, you will have a bunch of sheets. And whenever you open an Excel file, it's a good idea to just check out how many sheets you have. Otherwise, you may miss out some important information. So here's an exercise for you. Explore all the tabs in the ribbon and just try clicking on each action button to see what happens. And if you can figure it out, that's great. A lot of them are designed to be fairly intuitive. And if you can't, maybe just look for a tutorial or an explainer video online. Every time you hover over a button, you will be able to see a tip. And if you want to see what bottom align does, you can just click bottom align and see what happens, or you can look that up. And in general, with any tool or any software you're using, it's always a good idea to spend some time just exploring everything that it has to offer, because some of these things might save you time later. So let's talk about workbooks, sheets, and cells. Files that you open using Excel, the native file extension that you use with Excel, is the workbook. So currently we're looking at a workbook here, and just to quickly show you how I got to this workbook, I have this workbook file, data analysis with excel.xlsx, on my desktop, and just double clicking on it opens it within Excel. And within this workbook, there are multiple sheets. But if you want to create a new workbook, then you go to the file menu and you click new, and you can create a new workbook like this. So this is a new workbook called book 1, and this is a different file from this workbook. So let me just close that. And of course, you can save a workbook. Every time you've made some changes, you can save it, and you can also save as. So you can also create a copy of a workbook, and you have this option called save as template, which means You can save a workbook as a template and then you can use that the next time to create new workbooks. So that's workbooks, Excel files, and they have the XLSX extension. And a workbook contains one or more sheets, and workbooks can be created using the File New option. Now coming to sheets, a sheet is a grid of cells within a workbook, and this is used for data entry, it is used for computation. This is where you spend most of your time looking at data and entering data, manipulating data. And then sheets can be created, selected, renamed, and deleted from the bottom bar. So here you have sheet 1. You can click this button or you can just select a sheet here. So here the sheet is called introduction. If I want, I can change this to, let's say, loans. Let me call that loans. So you just double click and rename a sheet. And you can also delete a sheet. So here you have the option to delete. You can also reorder sheets, so you can move it around. You can see as I drag, it moves around. And I have a bunch of these sheets, but typically you just have one sheet when you start out. And you can add more sheets by clicking on the plus button here in the bottom bar. Now the bottom bar also gives you controls to zoom in and zoom out, so you can use those to increase or decrease the size of the text on each sheet. So that's sheets. Next we have cells. And this is what you're looking at here. This is called a cell. Every single box that you see on the sheet is called a cell. Into the cell, you can put a number, you can put some text, or you can put a formula. For example, if I type 3 plus 4, and formulas begin with the equal to symbol, you can see the output 7. And cells are the basic building blocks of any spreadsheet software, and every cell is identified by the column number, which in this case is E, and the row number, which in this case is 5. So you can see here E5, this is the cell number. If you want to select a specific cell, you can also type here, like if I type A2, that brings me to the cell A2. So that's about cells, and the value in a cell can be entered manually or can be computed using a formula. And you can select multiple cells by clicking and dragging and then perform operations on all those cells at once. For example, I can select all of these cells and then I can press delete to delete all of these cells. Not just that, I could also make them bold, or any operation that you can perform on one cell. Generally, you can perform on a group of cells once you click and drag to select a group of cells. Next, let's talk about rows and columns. So in the sheet, you have a bunch of columns. And if you click on the column name, it selects all the cells in the column. So all of the cells which are under the column C get selected here. Similarly, if you click on a row number, you can select all of the cells of the row. Now, one common operation that you will need to do is reorder columns. Sometimes maybe you want rate to show up before amount. So you can hold shift, and as soon as you see the hand symbol, you can actually drag the column around and use that to reorder columns. So somewhere here, you will see the option to reorder columns. Similarly, you can reorder rows as well. You can also do things like select a bunch of rows together and select all the cells, and you can just clear these rows. So you can clear contents like this, or you can even delete these rows altogether. So here I click delete. Yeah, and the rows got deleted. I think you'll see it better here. If I click delete, you can see that the content below has shifted up. So the rows got deleted. So you can move things around, you can shift columns around, you can shift rows around, and that makes a spreadsheet pretty flexible. You don't have to worry too much about structure initially, and you can improve the structure with time. So here are some exercises for you dealing with cells, rows, and columns. One thing you can also do is change the width and height of the different rows and columns. Like here, I've made the cell wider. Maybe I want to put more information here, and you can make rows taller. So if you want to draw more attention or give more space to a certain thing, you can do that too. So let's talk about data entry and formatting. Cells in Excel can contain three types of data. They can contain numbers, they can contain strings, and they can contain formulas. So you only have these three types of data in Excel, and everything is one of these. So let's talk about numbers first. Numbers in Excel can be whole numbers or real numbers containing decimals. So this is a number 3. 3.14 is also a number. 0.0009 is also a number. And to enter a number, you just click a cell and start typing, or you can also paste a value. For example, we can copy this number and paste it into another cell, and that works perfectly fine too. Now, in spreadsheets, you will often see things like percentages, dates, currency amounts, etc. All of these are recognized and stored as numbers within Excel. They're just displayed differently, and you can choose how a certain number is displayed. But it's important to note that all of these things, percentage, dates, currency amounts, etc. are just numbers. So I'll prove it to you. If I type 30% here, you can see that I can actually change the format. So if I go up here, this is called the number formatting dropdown. So I can go here and I can change it to number. And you can see that it is the number 0.3, as you might expect. Similarly, if I were to type $1,500 and I go and change the format here to number, you can see that this is a number as well. We can also do this with dates, interestingly. So let's type January 10, 2021. So first of all, you can see that Excel automatically recognizes that this is a date, and it is displaying the date in a particular specific format, 10 Jan 21 with hyphens. But you can again go here and select number, and you can see that this is just a number 44206. All the things that you can perform calculations with are typically numbers. There is the value, which is a number, and then there is the way it is displayed, which is called the number format. And you have this number format drop down in the home tab of the ribbon. And the number format can be applied to a row or a column or a custom selection of cells apart from single cells. So for example, you can see here, all of these are in the format of currency, and you can see the currency format. This is the number format here. This is the currency format. There's an accounting format as well, which just centers the numbers for you. You can show this as a date, but obviously that will not make sense. We are looking at amounts here. You can show this as a percentage, but once again, this will not make sense. The correct way to display this row of data is amount. Okay, and these are probably some loan amounts and then some rates of interest. And when you try to edit it, you will see that you actually get to edit the original value. One other thing you can do is here to change the currency symbol, you can just select that from here as well. You have a drop down. And if you want to convert something into a number, something into a percentage, you can press the percentage button here. Then you also have ways to add commas. So for example, if you have this large number, you can click the comma button and that's going to add commas for you. And you have ways to shift the decimals left or right. Like if I click this button, let me grab a number with decimals. So if I click this button, it's going to increase the number of decimals. And if I click this button, it is going to decrease the number of decimals for us. So you can use this to just format your data neatly. And you should check out all the different number formats that we have. And there are even more that you can check out in more number formats. So that's how you format numbers. And as an exercise, just try out each type of number, try creating a column for each data type. Try entering some numbers containing decimal points and then change the number of decimal points that you're displaying. Try creating a custom number format in Excel. If you go to more number formats, you can actually create a custom format. See if you can figure that out. And then try typing a date and a time into a cell and try changing its format. There are a bunch of date formats that Excel supports. Let's quickly look at one. Let's say we have Jan 1, 2021. Yeah, so now you should be able to change the format here. If you go to more number formats, under date, you have all these different date formats that you can use. For example, you can even put in the day here. And let's just put that in. And you can see here, we have Friday, January 1, 2021. Okay. So do explore the date formats. Depending on the kind of application, you may have to switch it around a little bit. So that was numbers. Let's talk about strings, which is just any text data. So when you're typing into a cell, Excel automatically detects whether the data you're entering into a cell is a number or a string. And one way to identify numbers and strings easily is of course to just look at the value, but also through the alignment. Numbers in general, you will find them aligned on the right, and strings in general, you will find them aligned on the left. So use that as a pointer. And sometimes if you see a number aligned on the left, that's probably an indication that maybe Excel is treating it as a string, and you may just want to convert that into a number. And one thing about strings is that if some text doesn't fit within the boundaries of a cell, then it generally overflows and is displayed on the next cell. So here is an example. If you go to the strings sheet of this workbook, you will see that here we have typed, is this the real life or is it fantasy? And that just shows over the cell C and the cell D as well. So we typed it into B1, but it shows up in C1 and D1 too. But if you had a value here like 32, then this would no longer show up and this would get clipped as you're seeing here. Now, if you do want to still see the entire contents of the cell, one way is to just click on the cell and you should be able to see it in the formula bar. The formula bar simply displays whatever value you have in the cell in the case of numbers and in the case of strings. The other thing you can do is you can click this button here. This is called the wrap text button. This is right next to the number format. And then you can wrap this text to multiple lines. And that's what you're looking at here. So these are some different ways to display strings and keep your workbook clean and presentable. And depending on the context, you may need to use any one of these. So the third type of data that you can put into a cell is a formula. So instead of manually typing a value into a cell, you can configure its value to be computed using a formula. And a formula must begin with the equal to character. That's how Excel detects that you're trying to type a formula. So to create a formula, you just type equal to followed by the calculation that you wish to perform, and then Excel will perform the calculation for you. Now, what makes Excel interesting is that in your formulas, you can refer to the values of other cells. For example, here we have amount, rate, and then we have interest, and we're typing a formula into interest. So we say equal to, and then we type A2. So we're referring to this cell. Then we have the multiplication symbol, and then we type B2. So we are saying that the cell C2 should have the value of the cell A2 multiplied by the value in the cell B2. So let's try that out. Let's go back here to introduction. First, let's try a simple formula just with numbers. So let's say we do 2 times 3, and that gives us 6. Maybe let's just try this out here. 2 times 3, that gives us 6. And in this case here, let us compute the total interest amount. And the interest amount in any loan is simply the amount multiplied by the rate. Now the rate you see here is 23%, but if you recall, the percentage symbol simply means that you're dividing by 100. So this is actually the value 0.23. When we do A2 multiplied by B2, we are doing $10,000 multiplied by 0.23. So that should give us 23% of $10,000. And that's $2,300. That looks fine to me. Now, if I also want to add a couple of decimal places here, then I can probably just press this button. And now I have 2300.00. And how do you tell if something is a formula? If you just click on a cell, you will see here in the formula bar, the formula that was used to compute the value. Now, of course, when you click on this cell, you just see 23%. So this data was entered manually, and on this cell as well. But here for C2, you can clearly see that it is a formula. So that's one way to detect if a cell contains a formula. Another way to tell is if you just double click into the cell, you'll go into the editing mode for the formula. And that's how you know that this is a formula cell. One other thing I want to show you is that you don't have to type things out. So you don't have to type out A2 multiplied by B2, although you can certainly do that. Once you type equal to, you get into the formula editing mode. So you can actually just select this cell A2 and then press star and then select this cell B2 and you're done. So then you press enter to execute the formula. One difficulty I often face is, let's say I'm in this mode and then I want to just get out of this formula editing mode. Sometimes I try to click outside while editing a formula, but you can't really do that. Like let's say I just want to come out of this view. What ends up happening is anywhere I click, it starts adding that to the formula. So the way to come out of formula editing mode is just to click escape, and that's going to just bring you out of the formula editing mode. Okay, so let's say you're in this position right now and you want to exit this formula editing mode, just press escape and you will be out. So that's formulas. You can see that something is a formula by simply looking into the formula bar, and there you will see the formula displayed, which was used to compute this value. And you can also check this by double clicking on the cell. Now, what makes formulas really useful in Excel is that they update automatically. For example, if you just want to figure out what would the interest be if the amount was $12,500. So just put in 12,500 and you can see that the interest changes to 2875. And that's because this value in this cell is tied to the values in these two cells. You can try changing the rate. What if the rate was 12.5%? So the interest changes to $1,500. And you can do this to test a lot of what if scenarios. And this is what makes spreadsheets so useful, because as humans, we are not very good at performing complicated mathematical calculations in our heads. So because it is so difficult, we tend to do less of it. And we tend not to evaluate different options simply because of the mental overhead of doing the math. So whenever you have certain options where you need to think through a few options and that requires performing certain calculations, that's when you should open up a spreadsheet. A lot of people are on spreadsheets all the time because they use it as a tool for thinking. They just offload any mathematical calculation that comes to their mind to the spreadsheet and get a result instantly. And that just helps you think through a lot of different scenarios very quickly. So using spreadsheets effectively in your day-to-day workflow is itself something worth exploring. So try this out, try exploring formulas, try exploring this what if kind of a scenario. Maybe pick some decision that you are considering in your personal life, maybe some kind of a purchase decision, some kind of an investment decision. Create a spreadsheet around it and just check out a few scenarios. Maybe you're exploring a few different mutual funds or index funds to invest some money in. So maybe get a bunch of index funds, get their percentage returns, get their percentage risk, and put in some formulas and see which ones you should invest in. So next, let's talk about formatting of cells. Now you can change the visual appearance of any cell or the entire spreadsheet or any range of cells. In fact, that is one of the biggest portions of the home tab of the ribbon. So you can change the font, you can change the size, text color, cell border, text alignment, etc., etc. And you can also apply styles like bold, italic, underline, etc. So we'll just try and replicate this kind of a structure here. So let us go into this sheet called formatting. And here we have the same data that we had in the introduction cell. So we have the same formula here too. And let's first put a border around this. So let's maybe put a border here. All right. Maybe let's make that a thick border. So you have the option of a thick border. And then let's add just separators between these columns. There we've added separators now. Let's add separators between the titles and the actual data. Let's maybe center the titles too. So I'm just going to click center align here. Sorry, that was vertical center align. I'm just going to click center align here. I'm going to bump up the font size to 14. I am going to make it bold, and maybe I'll pick a different font. Let me pick Inter. Yeah. Okay. Yeah, that's maybe too big. So let me just make it 13. You can change background colors and things like that. Let me add a background color here. Whenever you're changing colors, make sure your text is readable. Let's change the color of this. We can change this to green. We can change this to red. Now we have a style table. So use this to just give some sense of structure and some sense of hierarchy to your spreadsheets. Definitely you can go overboard with this. I think this is probably a bit too much. I would probably stick with simpler styles. but it just makes it a lot easier to parse what's on your spreadsheets if you have thoughtfully added borders and added backgrounds and added colors and such. Let's start using Excel for some calculations. Now, Excel formulas are commonly used to perform arithmetic operations on the values stored in other cells. That's the most common use case of Excel formulas. And these are the arithmetic operations supported in Excel. You have addition, subtraction, multiplication, division, percentage, this exponentiation, so you can raise a value to another number. You have the square root, and then you can also do the nth root. So the square root is actually a function, but you can do the nth root just by using the caret operator. So let's try out some arithmetic operations. So here we want to try out adding two numbers. One thing we can do is just do 2 plus 3. But of course, let's do this, A1 plus A2. And that's 44. Let's try subtracting. So that would be A1 minus A2. Let's try multiplication. Now I hope you're starting to get the idea. Percentage, let's say you want to find 10% of 21. So you just say 21 times 10. And that gives you 2.1. You can do a power. So let's maybe raise 21 to the power 3. So here we have, I type equals and select 21 to the power of 3. And that should give us 21 cube. Of course, we can also raise 21 to the power 23. That's going to be a huge number. And you can see that when the numbers get really large, Excel automatically converts them into the scientific notation, which means this is 2.5 multiplied by 10 to the power of 30. This is a very large number and it's just being displayed here so that Excel doesn't have to write out all the digits here, but this is actually a whole number. And just E plus 30 means 10 to the power of 30. So we are doing 2.57658 multiplied by 10 to the power of 30. Let's maybe take the cube root of 23. So here we have root and we just type 1 by 3. So when we want to take a root, we raise it to a fractional exponent. So A2 or 23 to the power 1 by 3 is the cube root of 23, 2.84. So these are the arithmetic operations that Excel supports. And in these formulae, you can use numeric outputs from cells containing other formulas. So for example, what you can do is you can maybe add the multiplication and this, whatever number this is, 2.34, and you can take the outputs which are themselves computed using formulae and use that to perform another calculation. Now the benefit of all this is that if you change any of these numbers, let's say I change this to 19, then notice the columns on the right, all of them update, and then this also updates. So you can create this chain of calculations where you have one number sitting somewhere and based on that you're doing a bunch of calculations, and using those calculations you're doing other calculations. And every time you want to try out something different, just go back and change the initial number. And that comes in pretty handy. And you can do this not just within the same sheet, but you can also reference numbers across sheets. One other thing you can do is you can construct complex formulae using parentheses. So using the round brackets, you can do something like add these two numbers. So this plus this. And then let's divide that by this number. And then you can perform a bunch of operations like that. And you see here, you get back a certain value. Let's now talk about how you can avoid having to type formulas repeatedly, because you're typically working with tabular data in Excel, like things like this. You have the amount and then you have a rate of interest and you want to calculate the interest amount. So what you can do is once you've calculated the interest amount, you can pull on this box here, this little box. So once you type out the formula here, you can just select this box and then pull this box down. So just drag this box down to apply the same formula to all of the rows of data. And let's try this out ourselves. So I'm just going to go into the fill handle. This box is called the fill handle. So I'm just going to go into the fill handle here, and I already have this formula filled in. So in the row 2, we have the amount multiplied by the rate, A2 times B2. That gives us the interest. Now, if you just go here to the bottom right corner, you can see that the cursor changes to a plus symbol. I can then drag this down. So I'm just holding my mouse down and dragging till the end. And this formula now magically gets applied to all the rows. So what's going on here? If you click into one of these rows, let me click into this, you can see that this is A5 times B5. And if you click this, you can see that this is A2 times B2. So Excel is smart enough to figure out that when you're dragging, you probably want this cell to be filled in by the multiplication of these two values, and this cell to be filled in by the multiplication of these two values, and so on. So this is how you auto-complete or you auto-apply the formula to an entire column by simply clicking and dragging on the fill handle. Okay, and Excel automatically figures out that it should make these changes. Now you may have a question, what if you don't automatically want to change this information? For example, let me do another exercise here. I have amount and then I have a fixed rate of interest. My rate of interest is 7%. Okay. And now I want to compute the interest. What am I going to do? I will click equals and then I will click E2 multiplied by the rate of interest. This seems to be I1 and I click enter. So this worked out just fine. But what happens if I drag this down? Suddenly we are seeing $0. So what's going on here? Let's see what happens here. When we are on this cell, we are multiplying E2 with I1. When we go one cell down, we are multiplying E3, and that is correct, with I2. So it turns out that Excel tracks relative cell references. When you said E2 here, Excel essentially kept track that I need to keep track of the cell that is just to the left of this cell. And when you said I1, Excel just kept track of the fact that I should go maybe 3 columns down and 1 row up and get that value. As soon as you move the fill handle, both of these references move down as well. And that's a problem. So what you can do is you can freeze a certain reference. Now, in this case, we do not want Excel to use I2. So we just want Excel to stay at I1. So we just put in $1 here. And when we put in $1 here, what we are telling Excel is do not change the value 1 if I move the cell around. Okay. So let's put in that $1 here. So nothing has changed here. It's still E2 multiplied by I1. But when we drag this time, you'll see the difference. So now it seems like the calculation went fine. So what happened? Here we have E2 multiplied by I1. And here we have E3, this is correct, multiplied by I1. So wherever you had the $, it did not change. And ideally here in this case, you can also put $I, $1 because you also don't want to change the column number. But since we are not really moving the fill handle left and right, so we don't need to worry about that. So that's one important thing, that there are different types of cell references in Excel. There is this relative cell reference, which is what is automatically used. So when you, what we used here is the relative cell reference. If we just move this in this direction, you will notice that here we had A2 times B2. And once we drag this formula over here, now we have B2 times C2, right? So A moved to B and B moved to C. That's a relative cell reference. Now, if you want to avoid that, the way to do that is to use an absolute cell reference. If you want to use and there are two types of, so you can use an absolute cell reference here. You can put a $sign both in front of A and in front of 1. And what that will do is that will freeze the value A1 here. So if I come back here and if I just put in $A, $2, now what happens is if I scroll down, you will notice that in all of these calculations, A does not change. You always have, 2 does not change. You always have $A, $2. Not only that, if I move it to this side, you will notice once again that $A, $2. This has not changed. You have $A, $2. This has not changed, but yeah, let's just expand that. But the second reference has changed. Okay. So just experiment with cell references. It can be a little tricky to understand at first. What does the dollar do exactly? So just pick up this workbook and try changing some of the references to dollar. Without dollar, try pulling it down, try pulling it to the right and see what happens. Absolute cell references is where you fix both the row and the column. Relative cell references where you fix neither the row nor the column. Both of those will move around in the formula. And then you have this mixed cell reference where you can either fix the row or you fix the column of a cell within a formula. And that's how you reference cells in Excel. Okay. Now you can also reference cells from another sheet by prefixing the sheet name and then using a exclamation mark followed by the cell address. For example, you can see here, I can reference from the introduction sheet, and from the introduction sheet, let me reference A2, and that's 12,500. And you can verify this here, that's 12,500. And in fact, if I go back in here and change that to 12,600, you can see that this number here changes to 12,600. Okay, so all you need is just the sheet name followed by the exclamation mark. Now if the sheet name has spaces, then you will need to again put quotations, put the sheet name in quotations, I believe, in single quotes. So just keep track of that too. And the fill handle can also be used to autocomplete any kind of series which Excel recognizes. For example, here we have a series 1 to 3, and if you just drag the fill handle, Excel automatically completes it to 8. And here it is able to recognize that you have the numbers 2, 4, 6. So it's going to fill in 8, 10, 12, 14, 16. Here you have Monday, Tuesday, Wednesday. So it's automatically going to fill the next few days of the week for you. Okay. So all you need to do that is just create a series. So maybe put in 3 values. 3 is always safe, although you can get away with 2 sometimes as well. So here we have 1 to 3, and I'm just going to drag it down and it fills in the values 1 to 9. Here we have 2, 4, 6, and as I drag it down, 8 goes up to the value 18, as you might expect. And you can try changing something in the series. Now, series are not dynamic as far as I understand. So if you change this to 2, 6, and 10, then these numbers will not change. So this is not a formula. This is just a guess that Excel has done, and it's just filled in some actual values. So if I change it to 2, 6, 10, and I want to replicate that jump between the numbers, so 2 plus 4, 6 plus 4, and 6 plus 4, and so on, then I would have to just drag it once again. Okay. Here we have Monday, Tuesday, Wednesday. Let's drag that. Let's extend this Monday, Tuesday, Wednesday, and that should go on Thursday, Friday, Saturday, Sunday, and so on. You have Jan, Feb, March. Now select them and drag down, and it takes us till September. One thing here to note is that if you just had Jan, that is not enough information for Excel, or maybe it is, I don't know. Let's see. So if I just type Jan here, yeah, it is, I think it is, but not always. For example, if you just had 1 here, it is simply going to create copies of 1 because it doesn't know what that series looks like. Jan is probably a special case because it already knows that in most cases you want Feb, March, etc. Then you have, you can do this, like you can type out proper dates, January 20, February 20th, March 20th, and then you can drag it down to fill in month and year. I think this is, yeah, so sorry, this is month and year. And then in fact, if we keep going here, you will find that it should be able to then fill in 2021 as well. So this January 2021, February 2021, and so on. Yeah. But of course, it cannot complete every series. So if you do apple, banana, carrot, maybe we have the alphabets in mind here, but Excel does not know what to do about this. So it's simply going to create copies of the data that you've given it. It does work with times too. So 7, 8, 9 AM, and let's just complete that, and you can get all the way up to 3, 4 PM or whatever. And of course, this doesn't have to be just hourly increments. So 7, 8:30, so that's 1.5 hours, and then 10. Let's see, hopefully this should work as well. It should be able to detect those increments. Yes, it is. With ABC, I don't think so. Yeah, this is not something Excel complete. So it's just something that you have to experiment with and try out. And one other thing is that this is not only possible in the vertical direction, but also the horizontal direction. So here we have January 1st, 2020, and January 8th, 2020, and January 15th, 2020. This is the American format, which is month, date, and year. And if I just drag this forward, you can see that it starts filling in some dates. And I think you can start to see the logic here. I'm skipping 1 week each time. So we have the 1st of January, 8th of January, 15th, 22nd, and so on. Now there are some interesting things. If you put in something like this, Q1, Q2, and let's try and complete this, you will notice that Excel goes Q1, Q2, Q3, Q4, and then starts putting in Q1, Q2, Q3, Q4 again. So here it is detecting Q1, Q2, Q3, Q4, because that's such a common use case, right? So they have a lot of such things programmed into Excel to make things easy for you. So that's how you auto-complete a series in Excel. Next up, let's talk about some built-in functions in Excel. Now, Excel offers several built-in functions to manipulate, combine, and process numerical and text data. And we've seen some mathematical operations already, but let's also see some mathematical functions. So here is a table showing you some common operations and functions. So if you want to get the total of a set of values, you can call the sum function. So here's how you do it. Let's say you have this information about students and their scores, and you want to get the total score that people have obtained across all the students. So you can just go here, type sum, and then you have two options. You can type B2, and then you can type a colon to start a range and go down to B6. And that should give you the sum. So that's one way to do it. Another way is to do it using a mouse. So you can type sum, and then you can just select this information like this. So click and drag to select this range and press enter, and that will give you the sum of the range. Now, of course, you can also do other things. You can compute the average, which is probably the more useful score here. Sum does not really make sense for adding things across students, but let's get the average score. Average score is 64. And then you can get the median score. Sometimes the median is more useful. You can get the maximum or the minimum in a range. So the maximum here would be, let's see, should be 90. That's the maximum. And you can check the minimum. And of course, you can put them all in different cells too. So here, let's put max and put that in a different cell here. So the min is 20 and the max is 90. So you can do that kind of analysis. And of course, if there's a change in one of the grades, if this goes to 25, just like any formula, the min and max and the averages and all those things are going to update automatically. And this doesn't just work with one column of data. You can also do this with a bunch of columns together. So for example, you have maybe, let's see, 26, 65, 72, 99. Yep. So if you have something like this, you have a bunch of columns. You can select a whole range of columns and you can get their sum. So let's just type sum here. And then let's just select this entire grid, and then it's going to work for the entire grid. So that 609 is the sum of all these numbers. Sometimes it also works with gaps. So if you have gaps here in the text, so let's see if you let's do the sum computation again. So we open sum, or let's do average this time. And let's select all of these. I think this should work too. So it's showing you 60.9, which means that it is simply ignoring all of these values. It's not putting in zeros here, because if you had zeros here, that would be a different thing. You can see that as soon as I put zeros here, the average changes. So it's going to ignore the empty cells. So it's smart enough to figure out. But that's just something to keep in mind when you're working with these multiple columns of data within Excel. Next up, we have these conditional functions. So we have two that are commonly used. One is the if, and the other is the exact conditional statement. So with the if statement, you first run a logical test, and if the result of the test is true, then it returns a certain value. Otherwise, you return a different value. So here is an example. Let's say based on the score, we want to decide if the person passed or failed. So we want to assign them a pass or a fail result. So I'm just going to type here if, and what is the thing that I want to test? I want to test that the score should be greater than or equal to 40. So if the score is greater than or equal to 40, then the person gets a pass grade. Now within a formula, whenever you want to type out a string or some piece of text, you need to put that within quotations, because otherwise Excel will try to interpret that as another function. So if is a function, that's why that is not in quotes, but pass is just a word that I want to return if B2 is greater than 40. Otherwise I want to return fail. Okay. And I run that, and you can see I get fail here. But when I drag this down, you will see that here we get pass, because again, the formula, because of the relative cell references, will now apply to the respective rows. Okay. So that's how you use the if statement in Excel. Let's try another one. This is the exact statement. So the exact statement is going to return true or false. So here's how it works. We type exact. So here we want to print true or false. And we have to mention the two things we want to compare. Now the passed column should contain the value true if the value in the result column exactly matches pass. So I want to make sure that D2 matches pass. If D2 matches pass, this should be true, but of course D2 is fail, so it does not match. But if I extend that down, you will notice here I get a true, because D3, this value, matches pass. And of course, if I now change the grade, if I change the marks for Biraj, if I change that to 35, you will see that this changes to fail and this changes to false. So that's how if and exact work. Then you have these logical functions, which are and, or, and not. And these are typically used to combine conditions. Now, if you see this if statement here we are just checking a single condition. If B2 is greater than equal to 40. If we wanted to combine, if we wanted to have multiple conditions here, we would need to use an and. For example, if we wanted to check that B2 is greater than 40, but not greater than 50. Okay, maybe or not greater than 80. So maybe let's change this to if B2 greater than equal to 40, and let's put an and here, and B2 less than equal to 80. Okay, if you wanted to put a condition like this, and let's just put empty here, let's not put fail here right now. So now we are going to check if B2 is greater than 40 and it is less than 80, then it's going to print pass, otherwise it's going to print the empty string. Okay, so here we get the empty string because B2 is not greater than 40. So even though you see empty here, there is actually a formula implemented here. So I'm just going to drag down the formula. And now you can see I get, because we are checking both these conditions, and both these conditions hold true with 60, both these conditions hold true with 70, but both of these conditions don't hold true with 90. So here we once again get a blank because B5 is not less than 80. Okay, so this is how you combine conditions. You have three types of conditions: and, or, and not, and then you have a fourth type called exclusive or. So here you have and a2 greater than 10 and b2 less than 5. This will hold true only if the value in a2 is greater than 10 and the value in b2 is less than 5. Only if both hold true. Otherwise it's false. Similarly, you have or. In this case, either the value in a2 is greater than 10 or the value in b2 is less than 5, and this holds true. Then you have the exclusive or. This will hold true only if exactly one of the conditions is met. Okay, so if a2 is greater than 10 but b2 is not less than 5, it holds true. If a2 is not greater than or equal to 10 but b2 is less than 5, it holds true. If both conditions are satisfied, it returns false. If neither condition is satisfied, it returns false. Okay, so this is a tricky one. Exclusive or, it's not very commonly used, but it's possible, it's useful sometimes. And then not simply reverses a condition. So just to go back here, one way we could have written this is if not b2 less than 40. So if b2 is not less than 40, then we return pass, otherwise we return fail. Okay, so that's not for you. Now here is an exercise for you. This grade column currently has been filled in manually, but can you use these conditional and logical operators that we have written so far and use them to compute the grade using a set rubric? So for example, if this is the score to grade conversion, 90 plus is A, 80 plus is B, 70 plus is C, 60 plus is D, 40 plus is E, and less than 40 is F. Can you set up the grade column in such a way using formulas that as I change the score or when I enter the score, the grade shows up automatically? Okay, it will require a fair amount of code actually between these functions. So it is a good tricky problem to try and solve. Let's talk about string manipulation. So Excel provides several functions to either break text or to combine text. Now, if you want to get some information out of some text, you can use these functions like left, right, mid, search. And here are some examples. So maybe let's try it out here. Let me get rid of this. Okay. So let's maybe just get the first three characters of every student's name. And let's call this the student code, first three characters. So the way we get the first three characters is we just do left and the text that we want to get, which is A2, the number of characters, which is 3. So AAK. Let's say if we wanted to also make them uppercase, I think you can just do upper and then that should just make that uppercase too. So that's AAK. And then once I drag this, that gives you all of these student codes. Okay. What if we wanted the last three? If we wanted the last three, then you simply change this to right. And that gives you just the last three. Okay. Now, obviously in this case, last three does not really make that much sense because you may have these spaces in between, but the first three characters generally shouldn't have a space. Okay. So that's left, right. Then you have mid as well. So mid can be used to extract information from the middle. Let's say we want to get character number, and in Excel numbering starts at 1. So 1, 2, 3, 4, 5, 6. Let's say you want to get characters 3, 4, and 5 out of every name. So then we would do, let's just clean this up first. Yeah, so then we would do mid and we want to use this text. Oops. We do mid and we want to use this text and we want to start at position 3 and maybe let's get 4 characters. So position 3, 4, 5 and 6. So we want to get 4 characters starting at position 3 and that gives us KASH, and then I can drag down and apply it to all of these. So that's left, right and mid. Then you also have the search function. So let's try search. Now let's say I want to separate out the first name with the rest of the name. So one thing I could do is I could just try and find the position of the space. So here is, first we want to mention what we want to search for. So I'm just looking for a space, and I am just going to find the space here in this text. And then I can also give a starting position to start searching. But in this case, I'm just going to search from the beginning. So what this is telling me is that there is a space at position 7. So now we have 1, 2, 3, 4, 5, 6, and then there's a space at position 7. And in this case, of course, the position of the space is going to change. So let's just call this space position. Okay. And using this, I'm going to define first name. So I want to get the first name out of Akash NS. And how many characters do I want to pick? I want to pick the number of characters that I need to pick till I get to the first space. So I will need to pick 7 characters to get to the first space. So I'm just going to do space position -1. And that's going to give me the name Akash. Now if I drag it down, you can see now we have Biraj, Siddhant, Vishal, Hemant. Okay. So just to quickly recap, we searched for the space character, and using that we got the position of the space character, which was position 7. And then we used the position of the space character in the left function to get the first name. And of course we can do this all together at once. So we can just do left and from Akashnes, and then we search, we search and we take the result of the search and subtract 1 from it. And that directly gives us, so that directly gives us the first name here. Okay. So a lot of these cases, you can just do this using a single formula. Akash, Biraj, Siddhant, Vishal, Hemant. You have left A2, search space in A2 -1. Then you can put things together. You can join text using the concatenate function, and you can also use this AND function. So let's say you have first names and last names here. So let's say you have the first names and last names here. Okay, and you want to put them together. So full name would simply be this, and then you put in an AND character and this. But of course you need a space in between. So we can add a space here and then use the AND character and join them together. And that gives you the first name. So that's string manipulation. Try out string manipulation with this data within the workbook. There are several other sheets within the workbook as well where you can try this out. Then you have date and time related functions, because dates and times is such an important piece of any kind of real world data. That's why Excel has a bunch of functions specifically for date and time. So here we have this sheet called date functions. Yeah, so in this sheet called date functions in the workbook, we have name and date of birth for a bunch of people. And this is, of course, this is the date, as you can see here. If you want to extract the year out of the date, you can type YEAR and then just type this serial number or just select this date B2, and that will give you the date 1981. And of course we can apply it to all of these. To get the month, similarly, you can just select the date here and that gives you the month number. So this is 1, 2, 3, 4, 1, 2, 12, 4, 8. Right, so this is the month number. 1 is January, 2 is February, 12 is December. You can of course also get the day of the month. So you can do DAY and given the same date. And this gives you the day of the month. And all of these could be useful in different ways when you want to combine data later. You can do weekday as well, the day of the week. So just type weekday. Oops. Yeah, so one thing I always miss is when you want to autocomplete, you press tab and that auto-completes a function. And let's get the weekday here. And that's a weekday. Okay. So 1, I believe, is Monday. 2 is Yeah, 1 is Monday and then 7 is Sunday. So all the numbers lie in between. Of course, this is not probably the format you may want to display things in. So what you may want to do is you may want to then convert it to text, and Excel provides a way to do that. So I think you do this, you type text and then you take the month number and you want to format it as a month. Let's say we want to get the 3-character month name MMM. So you type MMM and that's going to format this as a month. How did okay, I'm not too sure if this is the best way to do it, or maybe I should directly just select B2 here instead of D2. Yeah, I should be selecting, I should be putting in the date directly. So this is the numeric version of the month that we see here. If you want the textual version of the month, then we type text and then we select the date that we want to refer to, that we want to extract the date from. And then we are simply formatting it or printing it in this particular format. And this format currently that we are putting in is MMM. It's something I looked up earlier today. So it's something you can look up, how to print the month out of a date on Excel, and you should be able to find this. Similarly with weekday as well, I think there is a way. So I'll leave that as an exercise for you. Instead of printing 1, 2, 3, 4, 5, 6, try printing out Saturday, Sunday, Monday, Tuesday, etc. Okay. Then you can go the opposite direction. You can actually create a date from a year, month, and a day. And let's try and do that. So let's come back to birth date and let's see. So we want to create a date and we want to give in the year. We want to put in the month, we want to put in the day of the month, and that creates the date for us. You can maybe try and see if this works with this, if this is going to work with G2. I don't know. Okay, it doesn't work. So it needs to be a number. All right. So these are the kind of experiments. Just the good thing again with Excel is that you can experiment, but you can break things and then you can fix things easily right then and there. You can always go back, you can do Control Z. And you can also just keep saving versions and revert to specific versions. So use Excel to experiment. Whatever ideas you have, just try them out and you will see if they work out or not. Then you have these other useful functions. So you have this days function, which can be used to calculate the number of days between two dates. Just to give you an example here, you have 1st January 1981 and 3rd February 1990. If you want to know how much older Sherlock is compared to Alan, so you can Alan is compared to Sherlock, you can use days and then given this date and given this date as well. So you give the end date and then you give the start date and that computes the difference. So it turns out that you have 3320 days between these two dates. You can also display that as a month. You can also display that as a number of years. And the general way to do that is the date diff method. And I have just linked to the documentation here. So you should just check out the documentation to see how date diff works. Next, if you want to display dates in custom formats, then you can use the text function. So here's a quick overview of the text function, and this is the official documentation for Excel. So these are all, and the text function is used to format any data. So here, for example, it is used to format a number 1234.567. We want to format it as $1, comma, and then we want to show a bunch of numbers, and then we want to show 0.00. So let's actually try this out and let's see what happens. So if we take the number 1234.567 and we format it like this, that's just going to print $1234.57. You can see that it has been rounded to 2 decimals. Then we have this, we have this today function. The today function is used to get the date for today. Yeah, so that's the date for today, 7/4/21. And if you want to display it in a certain other format, so we can do that. Let's say you want to get the day of the week, then you just put in DDDD. So we put in equals text today DDDD, and that's going to just print Sunday. Or maybe if I want to use one of these dates, what's this, 3rd Feb 1990. So that was, I think that was B3 was the date. So 3rd Feb 1990 was a Saturday. Okay, so that's how you format dates, and then you can also format times. So if you have a particular time, you can format that in this hour, minute, AM, PM time. And you have a bunch of other formats. You can also format latitudes, longitudes. You can add leading zeros. Here's one way to do that. You can format things like phone numbers. So maybe check this out. This is how you format a phone number. 1, 2, 3, 4, 5, 6, 7, 8, 9. And maybe just for comparison, let me show you this. So yeah, this is the input and this is the output. So that's what the text formatting function does. It is all about just displaying data in a particular format. So do check it out. And you can try some date manipulation exercises as well. Now, one interesting function that depends on the use case that you may end up using a lot is the VLOOKUP or the vertical lookup function. The vertical lookup function is used to search for a certain value in a certain column in order to return a value from a different column in the same row. Now, it's easier to explain through an example. Let's say I want to figure out the score in math for the student with the ID C1004. So we have this large table with a bunch of student IDs and their marks in different subjects. And I want to do this simple lookup where I type a student ID and I want to just see their math numbers, right? It's like a search function essentially. So that's exactly what VLOOKUP does. In VLOOKUP, you first specify a value to be looked up. So the value could be C1004. And then you specify the table from which this value should be looked up. So when you have this, you have to select the entire range of cells which marks that table. And once you have selected that table, it is going to look up the given value in the leftmost column of the table. Then the third argument is to inform Excel which column from that table should be returned. So now we found C1004 in the table. Great, what's the big deal? That was the input that we was given in the first place. But now we want to get their score in math. So if we start counting the columns, column 1, column 2, column 3. So we want to get the value from column 3 of that table. And that's why we put column 3 as the third value. And then finally we can decide whether we want to do an exact match or an approximate match. And if you do an exact match, then you will get back this value 92 here. Okay, so let's implement this. Let's try this out. It's a pretty useful function. So here we have the same information. We have name, math, chemistry marks, and these are the names of people. And we also have the ID, the student ID. And what I want to do is I want to type in an ID here. And once I type the ID, I want to see the math score here. So I type equals and I type VLOOKUP. And then I am going to look up this value, whatever is typed into this cell. And I'm going to just select this table because this table is where I want to search. So the leftmost column of this table will be looked up for this value. Then I want to return, let's do chemistry maybe instead of maths. So maybe I want to return the chemistry marks. So that's 1, 2, 3, 4, column number 4. And I want this to be an exact match. So I'm just going to select false here. Okay. And this should be chemistry marks. So B1003, we get the marks in chemistry. And if I just change the student ID here to A1001, I should get Emily's marks. And then you can imagine that if we set up 2 or 3 such columns, so we can get the name, we can get the math marks and the chemistry marks. So we can convert this into a search box essentially, where we just type a student's ID and we get all of their information showing up here. Okay, so very useful function, especially if you want to have the search kind of functionality, and you have like a really large list of students, like 1,000 or so students. And just in general, what I want to mention is that a spreadsheet is a living document. It's unlike a database where you mostly just put data in, you don't really edit the database directly ever. A spreadsheet, on the other hand, is a living document. So here you have the data. This is kind of the database here. But then here you have this actual search functionality built in. You don't need to build a UI where you type something and then it makes an API request and gets information out. You can do all of that in Excel, and that's what makes spreadsheets so useful and handy for these one-off applications. So try creating a VLOOKUP cell to find the score in chemistry given the name of the student, or maybe just find all their scores as well. Okay. So with that, we've looked at just a small selection of functions in Excel, and there are many more functions. We've hardly scratched the surface here. So you can see there are some database, there are some date and time related functions. There are some engineering functions. There's some financial functions if you want to calculate returns, or you want to calculate EMIs and things like that. There are, of course, these information functions. You can get information about a cell using these functions. There are these logical functions and or not, if, etc. There are math and trigonometry functions. You can do sine theta, cos theta, etc. There are statistical functions. You can do standard deviation and such things. There are text functions. You can have user-defined functions as well. You can have add-ins which add functions to Excel. And then there are some web-related functions as well that have been added recently. Now you need not remember any Excel functions, and you can always look them up either in the documentation or just search for what you're trying to do online. For example, calculate the difference between two dates in Excel, or show a date in a certain format, and you should find a Stack Overflow answer, or you should find a link to a documentation page or a tutorial that tells you how to do it. Excel is probably one of the most widely used software programs in the world. So any question that you can think of has probably been asked before. So don't worry about trying to remember different functions in Excel. Now let's start doing some data analysis with Excel. Excel provides several utilities for analyzing and for visualizing data, and Excel's graphical user interface makes it easy to analyze data without having to write any code. So the first thing we'll do is to download a CSV file. So I'm just going to download this file, COVID-19 data for Italy for 2020. So I'm just going to save this to my desktop. All right, so the file is saved. This is a CSV file. This contains, let's take a look at the contents of the file. We have Italy COVID daywise.csv. And I am just going to open it with a text editor. You can see here, it has a date. It has a number of cases. So cases on that day, number of new deaths on that day, number of new tests conducted. Now number of tests is empty for till a certain point, and then we start to see the number of tests being conducted. And this contains data from 2019, 12/31, so 31st December 2019, all the way up to, this is September 2020. Okay, so we have this file that we just downloaded, and we want to import this into Excel. The way to do it is, generally you want to create a new sheet whenever you are working with any import or export. So I'm just going to call this Italy COVID daywise. It's always a good idea to name your sheets. And then we want to go to the file menu and do import, and then select CSV. So there's always ways, whatever spreadsheet software you're using, they have a way to import CSV files. So I'm going to import it. Open Italy COVID daywise.csv, and there are just some configurations that you may have to review manually. So this is a delimited file, which means that the values have a delimiter, the comma between them. So this is a delimited file. So I'm just going to do that. And what are the delimiters? Well, tab is not the delimiter, comma is the delimiter. So as soon as you select a delimiter or the separator, it's going to start showing you this in a tabular format. And then you can also select formats for specific columns. So you can click on a column and you can select a format for it. For example, here, this column date, I'm just going to call it a date format. It's not MDY, it is, I think, it is YMD. So it's in the YMD format. And then all these are numbers. So I'll just let Excel figure it out automatically. And then we can either insert it into an existing sheet or we can insert it into a new sheet. Now, since I've just created a new sheet just now, I'm just going to insert it into the existing sheet. Okay. And now we have our CSV imported into Excel. And this is the same way you would import it into any spreadsheet software. There may be a few options that are different, but roughly the process is going to look the same. This is what the data looks like. And one thing then you can do is you can maybe start doing some cleanup. Let's say if you want to call this date, you want to just make this new cases and new deaths and new tests. So that's a little nicer. I'm just going to mark this in bold too, just so that we know that these are headers. One other thing you can do is you can freeze the header cell, because as you scroll down, it may get difficult to see which column represents what. So there's a way to freeze the header cells, and I believe you can do that. Yeah, so I believe you can freeze the header cells in the view column. So yeah, if you go to the view tab of the ribbon, you have this option freeze top row. And what this does is now as you scroll, the top row doesn't move. So now as you scroll down, especially for larger data sets, this is helpful. You know that this refers to new cases, this refers to new deaths, and so on. Okay. So that's just some basic formatting. Now here's an exercise. Download and import the CSV file containing the population, GDP, and other health related information for various countries. Let's quickly do this as well. Should be a good recap. So let's download locations.csv, and I'm just going to go file, import, CSV, locations.csv. Okay, it's delimited. Comma is the delimiter, and I think I'm just going to skip this conversion, and I'm going to add it to a new sheet. So this is going to create a new sheet. This is called, let me just call it locations at the bottom. Okay, so now we have a couple of data sets that we have imported into Excel. We have Italy COVID day-wise, and we have locations, and we can do the same thing with location. We can maybe just mark this bold, and we can also freeze this header row here. Yeah, so that it's a little easier to read. Okay, as we go down. Great. So that's how you get data into Excel, especially from a CSV format. So if you can get data into CSV format, then you can load it into Excel, and you can also export this data out. Okay. Now that you know a little bit of arithmetic and you know how to use Excel functions, here are some questions that you can try and answer, and these are the same questions that we answered using pandas. What is the total number of reported cases and deaths related to COVID-19 in Italy in the given data set? Let's see if we can do that. So we go to Italy COVID day-wise, and I want to find the total cases. So I'm just giving it a label here, and that's going to be the sum, and that sum starts from this point, so which is B2. And here's a quick trick. If you press Shift, then you can use the keyboard to increase the range. And then if you press Command or Control on Windows, you can then press the down arrow and select the entire range at once. And you can see that the entire range is selected, and I can still see the formula that I'm typing in the formula bar. So I'm just going to close the bracket here and press enter. And now you see that now I have the total number of cases. So I have the total number of cases, and let me just put this above here, total cases. Now here's one interesting thing I can do. I know that the next thing I want is total deaths and total tests. Okay, so now we can start using some of the formula extensions in Excel. So I know that the column B will give me total cases. If I simply drag this here to the right, that's going to give me column C, the sum of deaths. And if I just drag this to the right, that's going to give me column D, which is new tests. Okay, so with that, we've just answered these questions, and maybe let's put in some commas here. It would be nice to see comma separated values, and of course we don't want any decimals. And I'm just going to drag this once again to also copy the format. All right, so the total cases are 271,515. Of course, we want to know what the start date and end date are. So let's get that too. I'm just going to put in something called start date here. And this is simply going to be the max or the min from the date column. So I'll just select this and go all the way down and then close. I can still see the formula in the formula bar. And there you go. So this is the start date. And what's the end date? For the end date, once again, I just go max and put in a number here and then close it. And that gives me the end date. So the start date is 12/31/19. The end date is 9/3/20. This is not a very nice format to read. So I'm just going to go here and convert this into, let's see, more number formats. For date, I would like to see something like this. So I just select that, and the end date, again, I would like to see something like this. So just select that. Okay, just going to make these bold. So this is how you do your analysis in a spreadsheet. Essentially, you just start creating new columns and you start putting in some formulas, and wherever possible, you try to reuse what you have already created. Okay, just going a little bit further, let's say you want to calculate the average. So you want to get the average cases. The way to do that would be, I would just copy this formula really. I would just copy this. I think copying and things like that are easier done from the formula bar. And instead of sum, okay. Yeah, instead of sum, I am just going to call this average, and that's going to give me the average number of cases. Once again, put in commas here and reduce the decimals. I just want a whole number here. So that's average cases, average deaths, average tests, and let's get that in as well. So the average tests per day is 143. The average tests is 31,700 and so on. Okay. Then you can also do like, what is the minimum number of cases on a day, maximum number of cases on a day. So this is how you start creating these statistics for your data set. Okay. You can figure out what is the death rate, which is the ratio of deaths to the ratio of reported cases. So the death rate, let's see, death rate would be the ratio of total deaths divided by the ratio of total cases reported. So that's 0.13. Let's convert that into a percentage. So that is about 13%. Maybe we want to get a few decimals in there. So 13.07% is the death rate. Okay. What fraction of tests returned a positive result? That's a positivity rate. What is the overall number of tests conducted? I think we've answered that, total tests, but except there is this additional piece that there are a certain number of tests that were not reported. So maybe we should also keep track of this number called unreported tests. So you see all these days, the data is empty for new test. So there was a single number that was given at the end that there were these many unreported tests. These many tests were conducted on these days, but were not reported on a daily basis. So we may then want to go back and modify our total tests computation to also include the unreported tests. And the total number of tests conducted is 5214766. So based on this, the positivity ratio can be computed. Yeah, so the positivity ratio would be the number of cases divided by the number of tests. And that would have to be a percentage. Let's get some decimals in there. So there is a 5.21 positivity ratio and there is a 13.01 death rate. You may want to clean this up a little bit, put them all in a line and put them side by side. But this is basically how you do some analysis in a spreadsheet. Now, one thing you may want to do is do some sorting and filtering, and that is really easy in Excel as well. So to sort and filter data, just select a range of data. I'm just going to select date, and now I'm going to use my keyboard. So I'm just selecting date, new cases, new deaths, new tests, and then I will just go down. I've held shift as I was selecting. If I don't hold shift, the cursor will just move, the cell will just move. So shift, select, and then I can go down one by one, but there are too many of these. So I'll just go command, shift, down, and that's going to select the entire range. Now I know there's a way to do this easily using the mouse too, but I can't recall it right now. But now we have, the important thing is we have the entire table selected. Now we go into this region here in the home bar and it says sort and filter. Let's just click that and let us just click the button filter. What does that do? That hasn't done anything yet. It has simply added these little buttons, these little arrow buttons or drop down buttons. And here is what we can start doing now. Let's say I only want to look at the data where the number of new cases is non-zero. So I can click this button that opens up this box, and in this box let's say I only want to look at data where the number of cases is non-zero. So here it contains all the unique values that are there in this column. Currently all are selected and I just want to maybe remove 0. So now once I remove 0, I can see that the first day was the 31st of January 2020 when more than 0 new cases were reported. So the first case was reported on 31st January 2020. Of course, there was no deaths till 2 days later and tests were still not being reported. Okay. One other thing we can do now is, maybe let me just put this back. Let's say I only want to look at all the days where the number of cases was greater than 1,000. So I'm just going to put in filter. So there's this option, there's this drop down here. So I'm just going to put in greater than. There are a bunch of selections here like top 10, bottom 10. Okay, maybe let's just check top 10 first. So if we just select top 10, this shows us the dates with the top 10 number of cases. Okay. So 20th March, 21st March, 22nd, 23rd, 25th, 26th, 27th, 28th, 29th, 30th. So it seems like in this entire year or up to September at least, these 10 days in March had the highest number of cases. Now, if you want to sort them by the cases, then we can also do that here. Let's say we want to sort them in descending order. So 22nd March reported the highest number of cases, followed by 27th of March, and then 21st of 29th of March and so on. Okay. So just using this one dialog, you can do a lot of analysis here. Now, of course, if you select this information now, if you look down here, you can actually see some statistics. Maybe it's too small, maybe you can't really see it, but now if you just want to know averages and such things for these, so in the top 10, the average was 5,700 cases per day during the 10 worst days. And the total number of cases in these 10 worst days was 57,187. Okay. So now as an exercise, what you can do is maybe clear this filter and find the days where the deaths were the highest, the days with the 10 highest deaths, and compute the average number of deaths in those 10 days and so on. But yeah, let me also clear this ascending, descending stuff. So yeah, maybe it's not. Yeah, I'll have to see how to clear the ascending and descending stuff. But one other thing you can do is you can use some of these filters. So I'm just going to look at days where the number of cases was greater than 1,000. So you can do such things as well. And then you can combine conditions. You can use and an or, and you can combine a bunch of conditions as well. Okay, so right now we are just looking at days where the number of cases was more than 1,000. Of course, we can combine conditions across columns. So now we are looking at those, just those rows where the number of cases was greater than 1,000. Maybe let's also track alongside the number of deaths being greater than 100. So how many days did we have where the number of cases was greater than 1,000 and the number of deaths was greater than 100? How many days did we have here? Well, if we just select this, we can see that there were 62 such days where the number of cases was more than 1,000 and the number of deaths was more than 100. Now, typically these kind of things I would note down in a new sheet, not in the same sheet, because what happens, as you can see here, is that rows are hidden from view. So when you apply a filter, it simply hides certain rows from view. So you don't want to put numbers into the same sheet because those rows may get hidden or displayed, or they may shift up or down. So I would probably create a new sheet and I would note down all this information here in using the data from the new sheet or using the data from this sheet. Okay. So that's how you do your basic sorting and filtering in Excel. And you can answer a lot of questions just by doing these things. I think I can turn off sorting here. So we can just say clear, and that's just going to turn off everything. Okay, I think it's still sorted in a certain order. I don't know. Yeah, seems like it is still sorted in a certain order. So maybe we should just sort it by date. And yeah, I think we're done there. Yep, you can remove the sorting and you can remove the filtering. You just go in here and you can select custom sort and then remove the sorting. You can just unclick filter and that is going to remove the filtering as well. Okay. There's one other thing you can do. If there is a certain common set of filters and sorting criteria that you apply to a sheet all the time, then you can save that as a custom view. Now I'll not get into that, but this is something that you can look up. Let's say you often need to look at the data where the cases are greater than 1,000. And from time to time, you also need to look at the data where the deaths are greater than 100. So these are two different views. What you can do is you can apply those filters and then save that view. You're going to view and select a custom view. So you can save a custom view and then you can reapply those filters very easily using custom views. Okay. So that's something worth exploring if you want to set up this spreadsheet for easy access and be more productive. Now you can try sorting and filtering with this locations CSV file. Here you have locations. So maybe one thing to try out is maybe just list the information for a certain continent, or maybe look at countries with a population of greater than 100 million. Maybe look at countries which have a maybe find the countries, the bottom 10 countries in terms of life expectancy, etc., etc. Okay. You can also combine columns of data. Let's say if you want to compute the GDP of the country, the entire GDP of the country, that would be the GDP per capita multiplied by the population. Yep. And that would give you the GDP per capita multiplied by the population. So that would be this multiplied by this, and that would give you the GDP of the country. And of course you can show this GDP as a dollar number. And now, so it seems like, yeah, for Afghanistan, this seems to be the overall GDP, which is about $70 billion. You can probably get rid of the decimals here. But yeah, $70 billion seems to be the GDP for Afghanistan. Okay. And then you can extend that to all of these. So you can just scroll down here and that will then get applied to all the countries. So that gives you the GDP for all the countries. Some of them, of course, some information is missing. So that's where you will see this hyphen. Here I have added this GDP. If I had just done this, that would also apply this to this entire column. Okay, so if you just double click on this fill handle, Excel is going to apply the formula to the entire column. Let's talk about pivot tables now. Now, pivot table is a way to group and aggregate values. So it creates a table of grouped values that aggregates the individual items of an existing table with one or more discrete categories. So what do we mean by that? Here's an example. Here you have a date, and then you have a bunch of new cases, new deaths, new tests, all of this information. Let's say we want to figure out how many cases you're having per month. How are you going to do that? So here's how you're going to do that. Let me just move this information a little bit. Let me just add a few rows here. Okay. All right. Yeah. So now we have date, new cases, new deaths, new tests. I am just going to add a month column here. And in the month column here, I'm just going to put in text, and I'm going to get this, and I'm going to get MMM. All right. Yeah. So now we have the month December here. And you know what? I'm just going to remove this column because I just want to deal with the data for 2020. So I'm just going to delete this particular row itself. I think we might as well just get rid of this for now. Yeah, so I'm just going to delete this row because I don't want to look at the data for 2019. Yeah, so I just want to get the month here. So I'm just going to type text, and I'm going to put in the value date here, and I'm going to put in MMM because I want to see it as a month, Jan. And let me double click on that, and that's going to just fill in the month for all of these rows. Great. So we have data from January to September. Now we want to get the month-wise totals. How do we do that? How do we do that? Well, we click, we select the data here. We select the entire table. And then we go to insert, and then we click pivot table. And this is a very versatile feature that you can do to use, that you can use to do a lot of things. So I'm going to do pivot table here, and it asks me to select a table or a range. So I've selected the range already. Otherwise you can select it here manually. Then you can either put this information into a new worksheet, the result of the pivot table, or you can put it into the existing one. I'm just going to put it into a new worksheet, and I just do OK here. Okay, so now we are in the pivot table construction mode. You can see here that there is a new sheet. You can see I'm in a new sheet at the bottom. And what do we do? Well, what do we want? We want for every month the total number of cases, the total number of deaths, and the total number of tests conducted. So here's what I'm going to do. I have a bunch of field names from the original column, from the original table. So that we have the date, we have new cases, new deaths, new test, month. So I know that my rows are going to be months. So I'm going to just drag month here, and that's going to make it, that's going to give me a bunch of rows, one for each month. Now, as soon as I drag something into the rows column or into the rows section, in the background, we now already have groups of rows from the original data corresponding to each value. So in the background, Excel has a group of rows for Jan. It has a group of rows for Feb. It has a group of rows for March. So all the rows for Jan are held together now. All the rows for Feb are held together now. Now what I can do is I can decide what the columns should look like. So the columns I want to see are cases. Oops, no, sorry, not that. Let me take that back. The columns I want to see are aggregates, right? So I'm going to drag new cases into values. And as soon as I drag something into values, what this does is it takes all the rows for Jan and it aggregates them using the sum function. Why is it using the sum? Well, that's the default behavior, but you can change this to compute the average. Let's say you want to get the average of new cases. So this is how you can get the average of new cases. So in the month of January, there were an average of 0.09 new cases every day. In the month of February, there was an average of 30 cases per day. In the month of March, there was an average of 3,253 cases per day, and so on. Let me change that back to sum for a moment. And I'm just going to pull in new deaths, and I'm going to pull in new tests. Okay. So you want to pull whatever column you want to aggregate, you want to pull that into values, and whatever column you want to group by, you want to pull that into rows. Okay. So if you're coming from a SQL or a pandas background, then the rows is where you select the column to group by. The values is where you select the columns to aggregate. And then you can also apply some filters. Let's say you wanted to only filter, let's say you wanted to only search for data between a particular date. So you can use date as a filter too. So I'll let you figure that out. But right now we have this nice table in front of us, and let's just give it some nice, let's just change the labels here. So let's just call this month, and let's zoom in, and let's call this cases. Let's call this deaths, and this is the tests. Okay. So this is the total information for cases, deaths, and tests. And then we can do our usual formatting here. Let me just get this in and maybe go back to home and put in commas here, get rid of the decimals. Same thing here. Put in commas, get rid of the decimals, put in some more, put in commas, get rid of the decimals. Okay. So these are totals. Then if you want to get averages, we could replace them with averages. So these we know are totals, but if we just double click here, we can change this to an average. We can also change it to a max or min. And if we want, we can get totals and averages by simply dragging it in once again. And this time, we just click this I button and select average. Okay. And I'm just going to call this average daily cases. Okay. So that's your pivot table for you. It is a combination of group by and aggregation. That's one way to create a pivot table. There is another way to create a pivot table as well. Something that we may be more familiar with from pandas, and we will cover that shortly. But I'm just going to rename this sheet for now. Whenever you create a sheet, it's always a good idea to rename. And this is month wise totals, right? So you can do that. Okay, let me show you another way to create a pivot table. This time I'm going to create another sheet. Let's just put in here year, month, and sales. Okay, let's put in something like that. So let's say the year goes 2012, and then you have 2012 a few times. Yeah, you have 2012, like you have 2012 4 or 5 times, 3 times, let's say. And then you have 2013 and 2013. Oops. 2013 and 2013. And here you have Jan, Feb, March. And then you have data for 2014 as well. Let's just call that 2014. And you have Jan, Feb, March. And then you have, so we have the year information, and then for every year of every month, we have some sales. So let's say here the sales are 40,000. Here the sales are 30,000. Here the sales are 35,000 and 12,000. Okay, and then just fill in some information here. So one other way now to create a pivot table with this is to select this information and click insert, click pivot table. And I'm going to put it in this same worksheet right now, and I'm just going to put it here in this position. Okay. And I've just created a pivot table. Now into this pivot table, what am I going to put? I'm going to use year as the row, and I am going to use month as the column. So now you see that the unique values of year become rows and the unique values of months become columns, and I'm going to use sales as the value. Okay. So what did we effectively do here? We took this information, which is year, year, month, year, month, year, month sales, and we converted it into this grid-like information where we have year 2012, 2013, 2014, Jan, Feb, March, and we also have a grand total. So in both directions, we have totals as well. So that's pivot tables. It's a combination of this pivoting and group by and aggregation. And that is mostly what you do for data analysis in Excel. You already have all these mathematical functions. You have sorting and filtering, and combine that with pivoting, and you have a pretty good data analysis tool with you. Next, let's talk about data visualization with Excel. Excel provides inbuilt charting tools to visualize data, and this has gotten pretty good over the years. So pretty much any type of chart you can think of, it's probably present in Excel, including maps. And the way to create a chart is simply to select the Add Chart button from the Insert tab. So we want to visualize some data, and here are some common types of charts. The first type of chart we look at is a line chart, and a line chart simply shows you information in lines. So here we want to plot crop yields. So we have the years, and these years we want them to show up on the y-axis, on the x-axis, and then we have the yield of apples and we have the yield of oranges, and we want to compare these two. So you want to create a line chart that shows the yield of apples, and apples are being shown in blue here. And these are the numbers it shows. For 2000, the yield was 0.895. For 2001, it was 0.91, and so on. And then we have the yields of oranges, which seem to be going down. How do we create this? Well, we select the things that will become the lines, and then we go into Insert, and then we select Chart, and you have a bunch of different types of charts. I'm just going to select line charts here, and I'm going to select lines with markers. If you hover over or just hold your mouse over it, you will be able to see this information. So I'm just selecting lines with markers here, and that gives me this chart. So I have the chart already, and let's start adding some elements to it. Let's give that a chart title. So let's just call it crop yields. And then you can also decide if you want to give it some kind of a background or shadow, 3D, etc. You can also change the text. You can change the type of text. Yeah, you have a bunch of things that you can modify about the chart. In fact, you can select this and probably just make changes using the home button, I believe. Yeah, you can change here, change this to enter and make this bold. So all these things can be applied. That's the chart title. One thing that's missing here though is the years. We have not added the years yet. So to add the years, you simply select the chart. So just click anywhere in the chart and go to the chart design tab. This shows up only when a chart is selected. You can see it goes away. Go to chart design and then click select data. And now here you can actually modify the data that has been put into the chart. And you can see that the data for apples is this, and here's where it picks up the label. And then the data for oranges is this, and here's where it picks up the labels. And here you can also select the data for the x-axis. So I'm just going to click this button here, and that allows me to select this range. So now I select this range and then click enter. And now I've just added axis labels, and you should be able to see that once I click OK. So you can now see that we have these axis labels showing up 2000 to 2011. What next? Well, I think it would be nice to maybe put in axis titles. So I am going to add an axis title horizontal and just going to call this year. And I'm going to add an axis title vertical. So I go to add chart element, axis title primary vertical, and this is yield in tons per hectare. Okay, that's looking nice. I may want to just slightly adjust the structure of the chart. I think you should be able to move the legend around. Yep, like that. Okay, so you can play around with the chart a bit. And then there are also some colors you can change if you want to change the colors of this specific, if you want to change the colors of this specific line or the specific series, you can do that. You can also select some predefined styles here. So there are a bunch of predefined styles that you can select from. I like this one. I think this looks nice. So here we have oranges and apples going up and down, and we also have this nice fade effect, and we have these numbers. It's a bit fancy, may not suit for every occasion, but you have a bunch of predefined styles to choose from, and you can modify any of these styles. Like you can modify the legend, you can modify whether you want to show markers or not, you can modify, let's see if we can do that. You can modify a bunch of different things. So I'll let you figure it out, and this is something that you can look up as well. How do you disable or enable the line markers? How do you disable or enable the shadow and things like that? Okay, so that's your line chart, and here's an exercise for you. Create a line chart to show the total number of tests and the total number of cases in Italy month by month using the Italy day-wise dataset. So you're first going to take the Italy day-wise dataset, do a pivot, get the month-wise totals, and then you can show the total number of cases as a line chart and the total number of tests as a line chart on the same line. And you can maybe use that for some sort of comparison. Let's talk about column or bar charts. So I am going to come down here to this one. Yep. So here we have some information about a few categories of products. Let's say we are an e-commerce web, or we are just a general retailer, and we have toys, we have shoes, and we have laptops, and we sell them in store, we sell them online, and we also sell them via mail orders. People send in mails. So in a particular month, let's say this is Jan 2021 sales. In a particular month, toys, this was the amount of sale we had. Let's just put in a dollar symbol here. Yeah. So this was the amount of sales we had on toys. This was the amount of sale we had for laptops, and this was for shoes, and this was for laptops. And now we want to show this information in a chart. We want to compare what the sales look like for these three. We want to compare them visually, and we also want to compare in-store versus website versus mail order. So how do we do that? So here's how we first let's just do in-store sales, and let's see what that looks like. So now we go into insert, we click chart, and we select from here. This is the column chart. So in Excel, bar charts are horizontal and column charts are vertical. So I'm just going to select this side by side column chart because I want to show these side by side. I want to compare them. Okay. So now we can tell that this is the data for toys, and this is the data for shoes, and this is the data for laptops. Okay. But what would be nice is if we could compare all three of these at once. So not just in-store sales, but also website sales and mail order sales. So I'm going to just delete that chart, go back here, go back to insert, select that. Okay. And now it's starting to look a bit more interesting. So now, but is this correct? I don't think this doesn't really look correct to me, because this says in-store sales, but this point is 22150, and this point is 137500, and this point is 17540. So it's actually these three things that are shown here. And this, we know that the category title should be toys here. So we may have to fix a few things with this chart. We will have to go back, select the chart, and let me just click select data, and let me fix a few things here. So first we have series 1. What is series 1? Series 1 seems to be the data for toys. So let's just call that toys. Or maybe let's just select the series data here, toys. Okay. Done. Then we have series 2. What is series 2? Series 2 seems to be this information. So that seems to be the information for shoes. So let's just select shoes here, and we're done. Then we have series 3. What is series 3? That seems to be showing this information here. So let me just select for series 3, let me select the name, laptops, done. So now we've named the series. Okay, this is series 1, which seems to be this row. This is series 2, this is series 3. So we have toys, shoes, laptops. Blue is toys. Toys is 22,000, toys is 43,000, and toys is 57,000. So 22, 43, 57. And then we have in-store sales, website sales, and mail order sales. So for in-store sales, you can see here you have 22,000 here, you have 137,000 here, and you have 17,000 here. So the in-store sales for toys, shoes, and laptops, and similarly the website sales for toys, shoes, and laptops. And you have the mail order sales for toys, shoes, and laptops. You may also want to display it the other way, where you show toys, shoes, laptops, and for each one you show the comparing in-store sales, website sales, and mail order sales. For that, you may have to probably just switch the rows and columns. I think that should probably do it. Let's see. I think that should do it if you change the rows and columns. Yeah. So now you have the sales for toys, sales for shoes, and sales for laptops. And we can also give this chart a title. Once again, if you go to select data, you just double click here on the chart title and you can edit the chart title, Jan 2021 sales. Okay. Okay, a little confusing, but with a little bit of experimentation, you should be fine with this. And again, you can change the styles. I think something like this would be interesting. Yeah, you're also putting in the numbers here. You can also format what the numbers look like. You can put a K instead of the thousands, instead of the full number, if you think that will help. Next, you have scatter plots, you have histograms. So let's check out those as well. Here we have some data. This is the iris flowers data. This contains information about how many, these are about 15 or 20 flowers. And for each of the flowers, we have their sepal length, sepal width, petal length, petal width, and then the species of the flower. Let's say we want to visualize sepal length and sepal width. So let's just select those two things and let's click insert. Yeah, and let's click insert and let's go into scatter plot here and select this scatter. Okay, so that gives us this scatter plot. All right, and this scatter plot, the values seem right to me. If you see this point here, this has sepal width of, okay, this is 4.6 and 3.4. That seems like one of these values, 4.6 and 3.4. The values seem right to me, but maybe we need to change the chart title. So this is sepal length versus sepal width. Okay, and maybe we should also change the axes, the ranges of the axes. So let me just select the x-axis maybe, and in the x-axis I can change the ranges. So here, instead of starting at 0, maybe this x-axis can start at 4. And the y-axis too, instead of starting at 0, maybe the y-axis can start at 2. Yeah, so now we have a nicer axis. We can also add in, let's see, we can add in the axis titles, horizontal and vertical. So the axis title here would be sepal length. And the axis title here would be sepal width. Okay. And with that, we have our scatter plot and we can change the style. Once again, go into chart design, try out maybe, yeah, that looks nice. So that's a nice visualization of sepal length and sepal width for the flowers that we have here. Okay. So that's your scatter plot. And similarly, you can have these histograms. So remember, histograms, they are used to visualize the distribution of a single variable. So I could select, for example, I could just select, say, let me move this away for now. But I could just select the petal length and just select the petal length column here. And then click insert. And then there's this statistical charts. And here I can select histogram. So I select a histogram and that gives me this information here. So it seems like between the range 1.3 to 3.6, we have 8 values of petal length or 8 observations of petal length. Between 3.6 and 5.9 we have 12, and between 5.9 and 8.2 we have 3 of them. How many bins should you convert, should you break this into? I believe you should be able to select that somewhere here. Okay, I would have to look that up. I've not done a lot of charting in in Excel, but there should be a way to change the number of bins here. So right now it has created 3 bins. Maybe you can create 5 bins and get a better idea. And let's just call this petal length. Okay, so that's your histogram. Your histogram is to visualize the distribution. Another way to visualize distributions is your is the box plot. So maybe let's continue, or let's go to petal width this time, and let us insert a box plot here. So I'm just going to go insert, and I'm going to select statistical chart, box and whisker, and there is your box plot. So this is your box plot, and this is displaying petal width. So what does this tell us? Well, this tells us that, I think we don't need this. So this tells us that the minimum value of petal width is 0.2 and the maximum value of petal width is 2.2. Then these are the quartiles. So the boxes represent Q1 and Q3. So 25% of the data lies below this quartile, 0.3. That means 25% of the data is less than 0.3. And then this is the 50% mark, the 0.1, 1.5. So 50% of the data is less than 1.5. 50% of the data is above 1.5. So you can see a bit of a skew here. And then this cross here shows you the mean or the average. Okay. So that's how you visualize the distribution using a box plot. So both box plot and histogram are useful. Box plot gives you the quartiles and the median. Histogram gives you interval wise distribution. And you can do that for all 4 as well. You don't have to just do it for a single column. So I'll leave that as an exercise for you. And this is just a small selection of the charts that you have in Excel. You can do a lot more with charting and visualization in Excel. Now we will just cover a few advanced features very briefly. These are not things that you will be using very often, but these are still handy to have. So the first thing I want to talk about is data validation and selection dropdowns. Now, because spreadsheets are often used as a living document for data entry and analysis and visualization by multiple users, they are quite prone to human errors. It's very easy to make mistakes, especially with data entry. So Excel provides a feature called data validation, which can be used to impose restrictions on data that can be entered into a selected range. Okay, and I'll show you what I mean in just a second. And optionally, you can even show a drop-down of acceptable values for a particular cell. So let's check out the data validation feature. It can be accessed from the data tab of the ribbon in Excel. And here's the example that we will work with. We have a list of names, and let's say these are the names of students. So let's just call them students. Okay. And now we are collecting results for the math exam. Okay. So math exam marks, we're just putting those together. So here we want to have, let me just do it here. Yeah. Math exam marks. And here we want to pick a student, and then for the student, we want to note down their marks. Okay. Now, ideally what we want to do is we want to make sure that the student name that I put in comes from one of these students. So one thing I could do is I could type each time John Burnett, but that makes it prone to errors. Like I could just miss a T here. So what do we do here? Well, here's what you can do. Let's say you expect that you will be doing you'll be putting in information about 100 people or so. So I just select a range, and then I go to data, and then here I click on data validation. Yep. So it's a small button here, data validation, which has a tick and a cross, and I click on data validation, and here I can specify that right now it says this current selected range allows any value to be put in. I want it to be part of a specific list. Okay. I want it to be picked from a specific list, and that list is something that I can select here. So this is the list of allowed values for these cells, and I enter that. And then I can say what to do if something is blank, and that's okay. Something can be blank, that's not a problem. And I can also show in cell drop down. So what's that? Well, if I click OK now you will see that I can just click this drop down and actually select this number like Carly Fisher, and then select this drop down, select Freddie Collins, click on this drop down, select Susan Hill, and so on. Okay. Going one step further here, you can also customize, maybe let's see what happens if I try to put in a value that isn't there. And it simply gives me an alert that the value doesn't match the data validation restrictions. So if I click retry, I can retry. And if I click cancel, it will throw me out. So what I can do is I can also just modify. Yeah, I can also modify the rule that is applied here. So maybe I can just go here in data validation once again, and I can provide an input message. When the cell is selected, show this input message. The title of the message would be, please select a student from the drop down. Please select a student. Let's just put it at that. And error, when the user enters invalid data, the title would be student not found. Make sure to select a student from the drop down. Okay, let's see if that helped in any way. So now when we go here, should see an input message here. I don't see it. But if I select an invalid value, now that prints out student not found. Make sure to select a student from the drop down. Okay. Yeah. Yeah, I should see an input message here as well somewhere. But that's what data validation is. You can restrict the values that go into a specific range of cells. Okay. I'm just going to put a border here. Here's another example of data validation. I would want these just to be numbers, and I would want these to be numbers between 0 to 100. So I can go in here into data, select data validation, and select whole number, and I want these to be whole numbers. There are no partial marks here, so the minimum can be 0 and the maximum can be 100. Okay. Now there's no drop down business here. Now it's simply a number that I put in. So if I try to put in by mistake, if I put in that, it will not be allowed, and I can customize this error message. But if I want to put in like 20, that's allowed, but 20.5, 20.5, that's not allowed. Okay. So that is again a good way to limit things here. And you can also customize this. Let's say you only want to have multiples of 10, you can do that too. So whenever you are setting up a spreadsheet which other people are going to edit, then you probably want to set up some form of data validation. And as an exercise, you can maybe just check out all the possible forms of data validation that are available in Excel. I think you can see whole number, decimal, list, date, time, text length, etc., etc. So you can also limit the amount of text that you can enter. Maybe you can limit it to 140 characters. This could be the limitation of the name of the students or comments from the math teacher or things like that. And you can set up custom validation criteria too. Okay, so that's data validation. And here are 11 examples of data validation. So you do check this out. The next thing I want to talk about is conditional formatting. Sometimes it is useful to show some visual information. Like in this case, we are color coding the marks of a student using a color scale. Anybody who's getting very low marks gets a red, and anybody who's getting a high mark gets a green. And we can configure how this works. So this is called conditional formatting, where you're changing the styles of a cell based on its value. And this feature makes it possible to just visually convey and highlight important information. And this is available as an action button in the home tab of the ribbon. So it's not too hard to find. Let's find this input. So there's this conditional formatting sheet here, and we want to add a conditional formatting here. So we want to show some color to indicate how well the student has done. So I'm just going to click conditional formatting at home. So in home, we have this conditional formatting, and there are many rules we can use, or there is this data bar. So let's try this data bar. This looks interesting. So this is simply going to show a bar of data behind the cell, and the more filled the bar, the higher the score. So that's one thing you can do. Or let me just remove that. Let's try the color gradient, color scale. So let's have this, there are a bunch of color scales here. So I probably want to have green, yellow, and red. Yeah. So red to show very low marks, yellow to show somewhere in between, and green to show the highest marks. And through this now you can very quickly tell that Vishal has probably got the highest marks, Akash has got the lowest marks, right? So just use this to add that visual element. So because we respond much faster, or we are able to grasp information much more easily when there are colors involved. It's a lot more vivid when the color conveys some information rather than numbers. We're actually pretty poor at processing numbers and just especially ordering numbers, but we're very good at ordering colors based on a color scale. And these are some natural color scales that are present. Of course, you can also do this. You can also configure a rule manually. You can go in here, you can click new rule, and you can say if the, okay, type number, I see. So if it is less than 20, you can set up, this is like a 2-color scale. So where you have low and high, and the low is 20 and the high, let's set the high to 40, and let's just see what happens when we put 20 and 40 here. So you can see anything below 40 or anything between 20 and 40 becomes red, anything above 40 becomes white, and you can, yellow. You can check this out as well. So 40 is yellow, 39 is, I see, I think maybe it's the other way around. Let me just fix that. So we go into conditional formatting, new rule. Something that is above 20, something that is below 40, we want that to show up as red. So the low value should be 0 and the high value should be 40. Okay, and above 40 is pass, so we want to show that as green. Below 40 is fail, so we want to show that as red. Let's do okay. Yeah, so this is what we are going for. Below 40 you have red, above 40 you have green. Okay, so it takes a bit of, there's a bit of a learning curve here, and you can look at a few tutorials and try and figure it out. But once you figure it out, you just have to apply the same thing again each time. All right, so that's conditional formatting. The last, most probably one of the most advanced features that you will not use very often, and that's not easy to do in Excel, is merging data from multiple tables. Now Excel doesn't provide a very straightforward way of joining or merging two tables. For example, here we have a store ID and we have a date, and then we have sales, and then against the store ID. So this is the sales information for a bunch of stores, and you can see we have Jan 1st information for the 3 stores, Feb 1st information for the 3 stores. So these are probably monthly sales for January, February, March, and so on. And we may want to just augment this information with some information about the store, maybe get the city name, get the area, and get the number of employees and things like that. So there's this one table, and we want to join this table, or we want to merge this table. If you have use the pandas terminology, join is more SQL terminology. So you want to do an outer join between this table and this table. It would be a left outer join between the table on the left and the table on the right on the store ID column. And that would give us all this additional information about the store. This is not that straightforward to do in Excel, but there's a trick. You can kind of do this using VLOOKUP. So let's take a look at that. Let's take a look at merging data. So here we have the data for the stores, store ID 1 to 3, New York, San Francisco, and Austin are the cities. And you have the area and you have the number of employees for each of these stores. We want to bring that information here. How do we do it? Well, I'm going to use VLOOKUP here. So I'm just going to put VLOOKUP. Okay. And what's the value I want to look up? I want to look up the value store ID A2. And where do I want to look it up? I want to look it up in this table right here. So the leftmost column of this table is going to match with the store ID. So there are some restrictions here. And then once I look it up, what information do I want to get? Here in this column, I want to show the city information. So that's column 1, column 2. So column 2. And I want to do an exact match. So I'm just going to put in false here. And there you go. So now here I have the information New York. How did that come in? We took A2. We looked into this table that is selected here. We found A2, or we found the value 1, and the value 1 is here. In that row, we wanted to get the value in the second column. So column 1, column 2. So we got the column data for New York, and then we put it here. Great. So that's the data for New York. And if we just drag this, it almost works. So what's going on here? Let's see, there's an issue here. So it seems like this table range has changed. We probably don't want to change this table range. This table range should remain fixed. So I'm just going to go back here to New York, and I'm going to just insert a bunch of dollars here because I want to keep this table range fixed. And I just want to change A2 becomes A3 and A3 becomes A4 and so on. So I'm just going to keep that fixed, and I am going to click enter. Now this time, as I drag, you can see now we get New York, San Francisco, Austin, New York, San Francisco, Austin, New York, San Francisco, Austin. So this is now the city information that came in. Okay, so you want to pull in the other information. You want to pull in what's next. You want to pull in the area information. So let me just call this area, and I'm just going to paste my VLOOKUP query, except that this time, instead of getting the column number 2, which is city, I get column number 3. And that's the area in square feet. And similarly, we can get the employees. And this should be easy now. We just paste this in here, but this should be A2 and this should be 4. And now we have the list of employees. Okay. So there is a slightly hacky way to do joins in Excel between two tables, and then these tables can belong to different worksheets as well, but it's not that straightforward. It's not as easy as saying join on store ID. Okay. And there are slightly better ways to do it using the index and the match functions. So I'll let you check out this tutorial to learn more about that. One other thing is about merging cells. This is a different kind of merging. This is not about merging data. This is simply about merging cells for visual display. Like let's say we have this table here. We have product and then we have monthly sales for January, February and March. It looks a little ugly here. It looks because monthly sales seems to only apply to the column B, but it applies to column B, C and D. So it would be nice to maybe just show monthly sales somewhere in between. And the way to do that is to merge these cells. And how do you merge them? There we go. So you see this option. This is the merge and center option. So you can just click on this drop down and select merge and center. And now it has taken this entire cell B1, C1, D1. It has taken all three cells and merged them into a single cell. So in some sense, it is in fact breaking the grid structure of the sheet, but it's making it slightly nicer to look at. So you can merge vertically, or you can merge horizontally, or you can merge vertically. Let me merge this vertically. So I'm just going to merge these cells and I'm going to center product vertically and I'm going to make it bold. Yeah. And that looks nice. That looks much nicer. Now you can see that you have monthly sales and that is divided into January, February, March, and product where you have shoes, laptops and phones. Okay. And you can select any grid of cells and you can merge them together like that. And then you can put a value in this, some title. and you can also vertically center it and change its styles and such, and you can change its background and all that. So use that to set up spreadsheets in the way you want to use them. And Excel is a very versatile tool. It's what we've covered here, even despite all of these things, is still only a very small fraction of what you can do with Excel. Although these are some of the most common actions that you will end up doing. So hopefully this gives you a good starting point into Microsoft Excel. And one thing that you should prefer for your personal work is to just use Google Sheets. And Google Sheets is a browser-based alternative to Microsoft Excel. And it's a great choice for personal projects for a couple of reasons. Google Sheets is free to use for personal use, unlike Microsoft Excel. And Google Sheets runs entirely in your browser and doesn't require you to download or install anything. So it's light on your computer too. Microsoft Excel is like a half a gigabyte download, I think. Then Google Sheets documents are stored in the cloud in your Google Drive account. So they can be accessed from anywhere, anytime. You don't have to worry about losing your data. And then Google Sheet also supports real-time collaboration. So if you just open up a Google Sheet, and by the way, a quick shortcut to open up a Google Sheet is sheets.new. And that opens up a Google Sheet for you here. And this is what it looks like, pretty similar to Excel, except that it's a little less busy. The interface, it actually has most of the functionality, but it's hidden behind these menu buttons. Yeah, it is backed up on the cloud and it supports live real-time collaboration. So if you just take this link, share, and you type the name of somebody who you want to share this sheet with, I can share it with Siddhant. And if Siddhant opens up the spreadsheet, I will be able to see a cursor for Siddhant. And as he types, I will be able to see the things that he's typing. So it's great for live collaboration. In fact, you can also chat. There is a chat here somewhere. Yeah, this is okay. So people can comment on things here. So people can comment here directly. You see this option. So if somebody has a comment on some data you've entered, they can add a comment. And that's different from the content of the cell. So here's a comment, and then the comment can be resolved. So you can kind of use it as a to-do list as well. So that's very nice. There's a lot of things that you can do with Google Sheets, much of which you can't do with Excel. Although Excel too has an online browser-based version, which is part of Office 365 and OneDrive. So you can check out those too. And then there are some new tools like Airtable, Notion, and Coda that combine features of spreadsheets and documents. So those are worth checking out too if you want to do more with spreadsheets. But the basic idea is you should be familiar with spreadsheets. You should be able to manipulate data. You should be able to do some basic analysis, and you should be able to do some basic visualizations. You shouldn't need to ask for help. Of course, you can look things up online, but for the most part, you should be proficient enough to figure things out on your own on how to do a certain thing in a sheet. Okay, so here's an exercise for you. Replicate everything we've done in this tutorial on Google Sheets and see if you notice any major differences between Google Sheets and Excel. So this is what we covered today: an introduction to spreadsheets in Microsoft Excel, a quick tour of Excel's user interface and functionality, using formulas, arithmetic operations, and functions in Excel, data analysis and visualization of real-world data with Excel, data validation, conditional formatting, and merging cells and even merging tables using the VLOOKUP trick. And also very briefly, we talked about some cloud-based spreadsheets that you can use for collaboration as an alternative to Microsoft Excel. Now, to learn more, the best way is to use Excel for a personal project. Maybe use it for your finances, use it for your personal machine learning projects, or use it for something that involves numbers and calculations. Maybe you track your stock portfolio on Excel or something like that. And there are a bunch of exercises that you can take. So here is this set of 150 Excel exercises on this site called WiseOwl. So you can check out some of these. And there's also an official video training by Microsoft that you can look into if you want to get to know specific parts of Excel. Then you also have this nice YouTube playlist on Excel. This is like 100 or so videos. So you can actually So you can actually jump into any specific topic in Excel here and see a good example.